All right, guys, here's a little wrap-up video about the circuits lab. Hopefully you have already done the lab before you watch this video. Okay, please do it first and then watch it, or else you're not going to learn it. I just wanted to wrap up a couple of things, okay? Basically, when we're looking at this simple circuit, you should have made this on the simulation, okay? You have the batteries here, and they must be facing the same direction. So you know how batteries have a positive and a negative side? The positives have to point the same way, and the negatives have to point the same way, okay? You're going to have a switch here, which you opened and closed, and the light bulbs, all right? You should see when you close the switch, the light bulbs come on at the same time. A lot of people do not really believe that that's actually true because they misinterpret what's actually happening here in the circuit, okay, which we'll talk about a little bit more when we get down to the batteries, okay? But yes, they do come on and off at the same time. And in order for the light bulbs to light and the circuit to be what we call complete, there must be a complete closed path. Okay, so when you open the switch, or if you take off a wire, or if you unscrew a bulb, any of these things breaks that loop, and then the circuit will not work. Okay, so that's what you should have gotten out of part one. Okay, part two, what is happening in the wires? This is kind of important. So this one, you should have watched the video. All right, batteries again are facing the same direction, and we had this little compass. And the compass doesn't move a lot, but hopefully it was enough that you could see it. All right, so basically what is happening after you close the switch is the battery sort of acts like a pump for the charge. Okay, so charge is actually the electrons, okay, in the atoms within those substances. But for physics terms, we're just going to call it charge, okay? And the battery, when the loop is completed, the battery's job is to sort of pump those charges around, all right? So when the battery is facing one way, you'll see the compass needle deflect a certain way. It doesn't mean clockwise or counterclockwise, it's just some direction, okay? The battery's job is to do the pumping, all right? So when you turn the batteries around to face the other way, that pumping action forces the charges to move in the other direction in the loop. That's why the compass needle switches the other direction, okay? So the battery's job is to pump that charge around so that it moves around in the circuit, all right? And so that's what's happening in the wires, and the compass is an indicator that there's something going on in there, okay? Let's see. That's that part, I think, is good. Okay, all right. Conductors and insulators, this part you could use the simulation for. Okay, this should have been pretty easy. So basically, you're putting different things into the circuit to see that if it makes a complete loop, which means the light bulbs will light. All right, and what you should have found, hopefully this part was hopefully pretty easy, is that anything metal usually will conduct the charge and allow the loop to be completed. Non-metal objects in general do not allow the loop to complete and do not allow our charge flow. Okay, now there are some objects that are non-metal that can conduct electricity in certain scenarios, such as water, right? Which is why you don't bring electronics into the bathtub, and your body, right? Which is why you have to be careful around like high voltage electrical wires. So under certain circumstances, your body or water or other things in an extreme enough circumstance could allow the charge to flow, okay? But in general, we're gonna say metal things allow charge flow, non-metal things do not, okay? And in the homework HyperDoc wrap-up, there'll be a little video about that, okay? All right, this part's kind of important. So part four, how does a circuit obtain energy? All right, so for this part, you were supposed to have watched this video to watch me doing the Genicon. So the battery's job is not to create the charges, which is what a lot of people think, and you probably answered that on that intro questions, okay? The charges, as we say, already exist in all objects. They're just electrons that already exist in atoms that are in everything, okay? So every object, every part of this circuit already has charge in it. It's just not mobile. It's not moving yet, all right? So in order for something to move, what has to happen, right? We just learned in the last unit, there has to be some kind of energy, right? Energy makes everything happen. So all of the charges that already exist in this circuit, need some energy source to sort of pump them around. All right, so normally that is the battery. All right, the battery's job is to pump the charges that already exist in the circuit. And in this case, we took out the battery and we used this Genicon, which we're physically cranking around and around and around, taking my energy from my muscles into that Genicon, which is in turn giving energy to those charges, which push them around the circuit. And then we say that that's a flow of electricity. Okay, so the biggest misconceptions, right, are that the battery creates charge and sort of lets it out like a little clown car and all the little charges kind of like scampering out, which is not what happens. Okay, the charges are already existing everywhere around the circuit. They're already there. That battery just kind of gives the signal for all of the charges to start moving. Okay, which is why back in part 1, you saw the light bulbs come on at the same time, because there's no time delay for the charges to get there. They're already there. The battery is sort of like the general in the army that says, everybody go. And then once the general gives the signal for everybody to go, then all of those charges start moving around the circuit all together. Okay. So in the HyperDoc homework, there's a lot more readings about some of these things. The stuff about the electric potential and electric potential difference is probably going to be a little bit confusing, but do the best you can with it. But the main idea is just trying to show how the battery sends this signal, right? It's just like moving from a high to a low height, right? Like if you drop something, a ball is going to go from high to low. The charges do the same thing. They want to move from high potential to low potential, okay, which kind of creates this flow, all right? So hopefully after you do the HyperDoc, that will make sense. All right, but main ideas, number 1, the charges already exist everywhere. All right, they don't have to come from anywhere. They already exist everywhere. Second big idea, the battery's job is to pump the charges or to give the signal to move. The battery does not create the charge. It supplies the energy, okay? It does that by the chemical reaction that takes place in the battery, which you'll learn a little bit more next year in chemistry. The chemical reaction that takes place allows for that energy transfer from the chemicals into basically the circuit and moving those charges around, okay? When the battery dies, it's not out of charges, it's really out of energy, okay? So when we say we want to charge something, we're really not charging it, we're energizing it, right? You are taking energy from the battery and supplying it into the circuit. Okay, you're not supplying charge, you're supplying energy. All right. If you have any other questions, please feel free to contact us. Thank you.